Hi everyone. Okay, so today we're gonna discuss about how we can protect or how we can basically give access of your private network in such a way that it is highly secure all the time. Okay, what is a private network? Anyone knows that? Private network. Okay, so I'll just give you what exactly it is. It is basically uh, a set of servers or the network which is completely protected from outside access or it has a limited access for other people. So that is basically a private network. And when we talk about building solutions or using cloud solution, sometimes we need to provide access to our private servers or our private data to the cloud solutions. Now, how exactly we gonna give that access in such a way that we can keep a track what exactly the data which is being transmitted. Also, if there is anything that can be done for the highest level of security, so we're gonna see that why exactly that is required and how exactly that is being achieved. So the first thing which we wanted to discuss is what is network security. You must have heard about network security, right? Anyone can tell me like what exactly it is? It is written over there though. So basically, it is protecting a network from its data and unauthorized access or misuse. Like if there's any chances of happening anything in the network, so basically protecting your network from outsider attacks, insider attacks, and all those things. So that is basically the network security. Over here, you can see there is a server security. We talk about database security, different layers of applications, different layer of your servers. All of them require different level of security. So we'll basically talk about where exactly we can do what. Why network security matters? Again, as we said, because we do not want it to reveal our private data. We do not want it to make any cases where our servers are down because of outsider attacks or something like that. That's the reason we need cyber security or network security for our private servers. So why exactly we need it specifically for private servers? Because nowadays most of the solutions which are coming in the market, they are cloud solution. They only provide the cloud option for the solution. Now, if you do not use those solution as an organization, you cannot move forward, right? And to move forward, we need to use those cloud solution in such a way that the security is not getting compromised. So because we are relying most of the chances on the cloud solution, that is one reason why we need to provide additional layer of security over here. Apart from that, the rising cyber threats we are reading every day, there are a lot of new attacks which are coming every day, ransomware and many, many more them. So we wanted to make sure our networks are protected from that, even though we are using cloud solutions. Important of balancing functionality with security. Again, as I stated in the start, that we wanted to use those cloud solutions. We wanted to rely on those cloud solutions in such a way that we can do our functionality. So we wanted to manage that particular part, that the security as well as the functionality is being managed. Ensuring business continuity. Again, these applications are critical to make sure our business is running continuously. Now, why exactly we need to give access of our private network? We have discussed that, but again, we'll go through point by point. Allowing cloud application access from private network, like we wanted to give the private network access. Apart from that, there are some cases where we do have hybrid environments as well, or hybrid setups as well. Like some of your servers are residing in your cloud, and some of the servers are residing in your private network. Now, because some of them are in private and some of them in our cloud, so we wanted to make sure they both can communicate with each other in such a way there is no possibility if something wrong happens to your cloud servers, that also happens with the private network. So we wanted to make sure if anything is going wrong in the cloud, that should not replicate it in the private. User connectivity using VPNs. Nowadays, because of COVID and before COVID as well, people used to work from home. Now, if you wanted to give them access and you wanted to make sure that they are using it securely, we usually use VPNs. And these VPNs is something, I would say it's a way to give access to those private networks. There's one more thing. We also, in some organization, we also divide the network in such a way that the data from one department is not being shared with the other department. That is something like a VLAN sort of thing, where basically we are dividing the network in two particular ways, that is virtual networks. So if there's two private networks, and you wanted to make sure one cannot communicate with each other directly, there should not be a direct connection. So in that case also, we can keep a tunnel sort of thing, which can basically allow us to communicate with those two private networks. Okay, how exactly we can provide access to our private networks for remote people or remote access? So the best possible way is the VPN. VPN again is being used for making sure people can connect to the private network, servers can connect to the private network, and if there's any sort of data transmission required, the highest security possible for transmitting those data is the virtual private network. Now there are different type of VPN connection which can be used for different cases. For example, there's a client-based VPN, then we talk about site-to-site VPN, then we talk about SSL VPN, and there's a cloud VPN as well. Different VPNs have different purposes, and all of them are being used to just make sure the access is properly provided. The first thing which we'll talk about is the client-based VPN. Over here you can see that it is basically used for individual access. So if you are an employee of the organization and you are doing work from home, or you are not in the office premises and you wanted to access the private network, in that case this client-based VPN comes into the picture. You basically is a single user and you just try to authenticate using username, passwords, or the multi-factor authentication. This is just to make sure that you are the authorized person to connect to that network. And directly, because there is no direct access to the private network, it basically creates a tunnel sort of thing for that individual user. Again, it's a very simple, straightforward concept, like allowing the access to the private network. Now we'll talk about the site-to-site VPN, which is the most critical component. It is the critical component in both the ways, like if you are having your private network, in that case also it comes with a very specific plan, and if you have a cloud solution, or if you are planning to have a cloud solution or a SaaS solution, in that case also, because your customer won't be allowing you all the things all the time. So in that case, you need a solution which can basically allow your cloud solution, your SaaS solution, to communicate with your customer's network. Over here, this site-to-site VPN is the most common one, and how exactly that works, we're going to discuss about that. It is basically for network to network. Like if you wanted to connect two networks, this IPsec tunnel is being used. It is best suited for connecting two VPCs, virtual private cloud, or allowing cloud to access intranet. In the case of this, the normal authentications are pre-shared tokens, or you use certificates as well, or pre-shared keys as well. Over here you can see that in this particular diagram, I'm just trying to depict like there are two networks and they both are belonging to a single organization. One is their headquarter network and the other one is their branch office. Now this branch office contains the finance data or finance network. So we do not want the finance data to be transmitted to the people who are in the headquarters. There might be some software engineers who are working on there. We do not want them to have access to this particular data. So what we have done over here, we have two virtual private clouds, or you can say there are two private networks. One is the finance network and the other one is the headquarters network. What exactly happens in this particular case? We basically allow them to have the communication using the IPsec tunnel. So if somebody wants to have the access, we can define the authentication and the authorization on this particular layer, like what exactly they can access and how much they can access. The more normal use cases of this site-to-site VPN is basically having hybrid cloud integrations, connecting remote branch offices, which we saw just right now, protecting and encrypting network and application data. It can be your network data as well and your application data as well. When you're transmitting that data on the tunnel layer, you can basically define like how much the encryption should be there, and if you wanted to hash the data as well, that is also possible. Authenticating data and verifying data comes from the trusted sources. Like for example, if my private servers are communicating from the cloud, what exactly the data is coming with them. For example, if my private servers are communicating with a server which is basically sending some malicious code or malicious files, it will be able to identify them and basically encrypt them in case if there's any sort of requirement of that. Challenges in building the IPsec tunnel. Like what are the challenges when we talk about IPsec tunnel building? The first thing is the configuration complexity. When we talk about IPsec tunnels, the major part is their configuration. How exactly the two servers, the two private networks will be communicating with each other in such a way they trust each other and only the trusted people can communicate. Performance and scalability issue. IPsec tunnels basically relies on a tunnel. By default, internet has a wide range where internet can travel with each, or like the packets can travel. In the case of IPsec tunnels, it is basically a specific tunnel where all the data should be transmitted from that tunnel itself. Now, because that tunnel is transmitting all the data or having all that load, so the performance and scalability also becomes a very big issue over here. Security and key management concerns, because they require some sort of security and we wanted to make sure the communication, whichever communication is happening between them, is secure as well and encrypted as well. So those keys which are being used for making that communication secure also needs to be rotated and like managed very well. DNS and tunnel splitting, that is a key concept where we basically, for example, if I'm a user and I should have access to certain network and the other user should not have that access. So split tunneling is being used in that case. We basically divide the user on the basis of their role or on the basis of their access, where exactly they should be targeted or which tunnel they should use or which network they should be connected to. How it works, we'll discuss the technical part. Like there are total 5 steps, the major 5 steps are there. And whenever we are trying to build an IPsec tunnel, what are the steps we need to follow? So the first thing is basically endpoint detection or identification. So for example, there are 2 networks. We wanted to identify which network should be connected with what. But what access that particular network will be having, or what are the IPs that will be exposing with that particular IPsec tunnel, that we need to identify. For example, if I had 2 private networks, 172.0.0.1 or something like 192.1 as well. Now, we wanted to communicate between these 2 and we wanted to make sure only the 172 access should be given. So we can define the IP range for which the other server, the other side of tunnel can have access of. The second part is basically authentication. We can define if it is pre-shared keys or digital certificates or something like that. Then the third step comes, that is the phase 1 of IKE, which is basically Internet Key Exchange negotiation. Now what exactly happened in this particular steps? So when you want to build a tunnel, so the first thing which is there is we will be sending a request from our private network to the cloud if we are using a cloud server for the other side of tunnel. So if we do not have a public IP, we can directly use it in that way, basically sending a request from your private network to the cloud. That is the very first request. Now in this particular case, what exactly happens? We basically negotiate encryption algorithms, hashing algorithms and key exchange mechanisms. So all those exchange will happen in this particular step. It will basically create a tunnel called ISA-KMP, which is basically security assertion. It basically makes sure that the basic steps are done or the negotiation part is done. Then the second thing is IPsec tunnel negotiation. It basically establishes the main tunnel, like the one which can allow us the communication from both the sides. Whether it is your private to cloud, private to private, both the side of communication should work. If I'm sitting in 172, the other person is sitting in 192, they should be able to access 172 range which I have defined, and I should be able to access 192 range which is defined. Now in these steps, we also do the negotiation for encryption algorithms, integrity and all those things. The last step is basically data encryption and transmission. So whatever the data which is being transmitted, all the data should be encrypted with the encryption algorithm which is being transmitted or negotiated. Over here you can see the steps, how exactly all the things are working. Host, in this particular case we are using 2 hosts, host A and host B. and there's two routers as well, which is basically allowing us to send those packets or basically do the communication for us. So host A is sending an interesting traffic that I wanted to establish a connection with you to host B. Now router A basically do the job for the negotiation of the phase 1, and router A and B negotiate on the two session, and they basically communicate that this session can be established on the basis of the keys, encryption algorithm and all those things, and whatever the certificates you're using as well. Now once the tunnel is being established in the fourth step, whatever the data is being transmitted, that is basically encrypted as well. In the last step, basically whenever we wanted to close that terminal, we can basically close that tunnel as well. Now we'll see how exactly we can do this in the case of AWS. So because most of the organization does use cloud solutions as well, like AWS, Google, many more like that. So I'll just give you an example how exactly this can be achieved. The same thing can be achieved with your private network or VPCs, with any other private network, or with the case of AWS as well. So in the case of AWS, there are three options or basically three components of establishing an IPsec tunnel. The first one is virtual private gateway or the transit gateway. The second step is customer gateway device or customer gateway, I would say. In the virtual private gateway, it is basically for dedicating a single VPC. VPC is basically a single, you can say a range of IPs or something like that. And if you have a single VPC and you wanted to establish an IPsec tunnel, in that case you usually use virtual private gateway. If you have multiple of them, there's a different option. But if you have simple or you just wanted to have it for a specific VPC, this can be done with the help of virtual private gateway. In the case of transit gateway, it is basically for the multiple VPCs. If you have multiple VPCs and you wanted to attach it in such a way that multiple VPCs can communicate with a single tunnel, that can be done with the help of transit gateway. So you need to create that transit gateway that will be attached to your multiple VPCs, and those VPCs will be automatically, all the IP addresses of that VPCs will be automatically available for that IPsec tunnel. The other part is customer gateway and the customer devices or the gateway device. It is basically the other end of the tunnel. So you have done the AWS side of configuration with the help of transit gateway or with the help of your the virtual private gateway. In this case, this is the other side of the tunnel which needs to be established from the other side. In this case, usually people do use the customer gateways like VPNs, firewalls or something like that. If you do not have something like that, Minions also have a connector sort of thing which can basically get established on any Ubuntu server or Linux server, which can basically allow you to use that servers as a IPsec tunnel endpoint. This particular architecture basically shows you the full single tunnel architecture, how exactly it will look like in real world. So over here you can see there are 3 VPCs, and these 3 VPCs are attached with the transit gateway because there are multiple VPCs. We'll be using a transit gateway over here, and that particular transit gateway is basically connected with the customer gateway. Now this customer gateway is the on-premises in the data center, or you can say it is on the other side, it's a private network as well. Now this particular communication over here, this is the IPsec tunnel which we have established. Now the resources available over here in this particular case, like for example, there are 2 computers which is being shown in this particular picture. So those computers can access these particular VPCs, the private IPs, or the VPCs can also access these particular servers as well. The same way we can do it for multiple tunnels as well, or we can say split tunneling as well. For example, in this particular case, we have 2 different virtual private gateway which we have established over here, and they are associated with different VPCs and everything. Over here, we are basically having a tunnel over here, AWS Direct Connect location we can define, and there are different connectors or different networks can be connected over here as well, like the client, the mobile client, or even the servers as well. There's some additional security steps which we need to follow when we are creating those tunnels. Again, they can be required in different cases. If you are doing it for your own private network, then there will be different scenario. But if you're doing it for a cloud solution or a SaaS solution which you are hosting and you wanted to make sure you can access customers' private network with the best possible security, so in that case, there are different steps needs to be followed. That is least privilege access. If I'm giving access to my private network, I should make sure that I am giving the least privileged access or the minimum access which I can give. There should not be any user who can basically do all sort of activity in the private network. It should be very limited access. Whether it is for your VPNs or whether it is for IPsec tunnel as well, this case applies to both of them. Zero trust architecture, never trust and always verify. Basically make sure whatever the access you have given, it is always on the demand, not at the, like in the beginning or something like that. Whenever a user requires that access or whenever the tunnel requires that sort of access, it should be on the runtime, never in the start. Encryption standards, all the data which is being transmitted in that tunnel or all the data which the users are using as well, that should be encrypted and those keys should also be rotated automatically. Continuous monitoring, even though we have established the tunnel, even though we have given the access in such a way that only the required people can access or only the required servers can access our private network, we should also make sure that if there's any sort of data which is being transmitted, what exactly the data is being transmitted, and we also need to keep an eye on it. Something like we can also use AI over here, like whatever the data which is being transmitted, we are keeping an eye on that. And in case if there is any sort of operation which look malicious, that should be blocked as well. Last but not least, because these tunnels are like single point of failure, because all the network, all the communication is happening through that tunnel, we also wanted to make sure there is a high availability or a disaster recovery case for that. So for example, if your one tunnel is going down, the other tunnel should be there, which can basically do the task for you. And there should be a case in case there are particular dependency of making sure only the required people can access that particular tunnel, there should be a split tunneling for that. Okay, so I guess that is it from my side. Any questions or? Yes.
You said that within different VPCs, there will be a need for sharing of certificates as well, right?
Sharing
if we establish a VPN, still they would need their certificate authorities to make sure the connection is secure or not.
Like, let's take an example. If you have a multiple VPC architecture, so what exactly you need to make sure that there is a transit gateway, or basically a tunnel should be established. Now this tunnel should also make sure whatever the data is being transmitted, that should have, like, you should have an eye on that. Also, there should be a limitation in terms of, like, for example, if you're doing key-based authentication, so there will be a user as well. You need to define which IP addresses that particular user can access and how much access that user will be having. Whether they can just access those IPs or they can like put any sort of commands on those IPs, or they can basically like do an operation of bulk uploading on something like that. Like too many requests or rate limiting, there should be a rate limiting as well, that this particular tunnel should not have that much of range of request for a particular user or from a particular user, something like that. So there is a requirement of that as well.
Thank you.
So my question is regarding the connection when you have two entities establish a tunnel connection. So the data transfer happening in between them. So is that encrypted, or it would be open to both, or like it's unencrypted? How it would be?
It will be encrypted.
Okay.
The reason why exactly this whole tunnel looks like is there, just to make sure there is no man in the middle, first of all. And if as a private organization, let's take an example, if I have my private network, I wanted to make sure whoever is accessing that data should only be coming to those people who can basically read those data. So that's the reason the encryption is required. If that is not a trusted authority, they will not be able to decrypt the data.
So next question is on decryption part. So for example, the client side, they establish a connection with VPCs, okay? So probably they would be using either public keys to encrypt the data.
Yeah.
So in that case, like you have a set of devices or set of clients one side and other side. So how this data encryption would happen from in that granular level? Because device to device private keys may change, right? Or at the virtual VPC's end. So how this connection will be established and how you are keeping that?
So the keys which we are using, those keys have those capabilities. For example, if there's a private key which is being used, and both of these entities have their private key, and they use that key to encrypt the data and decrypt that data. Now we define like what level of access this particular key will be having. If somebody is having this particular key, so what level of access they can do. Also, there's a user as well. User authentication also happens. So when we establish the tunnel, we basically provide a file sort of thing in which all those details are mentioned. Like what are the private IPs they will have access of, what are the range also, the username and password and all those things. And if there is any sort of requirement of certificate as well, those certificate will also be available in that file. So that file needs to be uploaded on the other side of VPN or on the other side of the IPsec tunnel.
Got it. Thanks.
Oh, hello, hi. Here. Yeah.
Yeah.
So this is a common question, I believe. So if, for example, there's one VPC and on-premise data server, both have same IP range, right? So do you have any solution? Because that way we cannot like exchange data if both have same IP range. So do you have any solution to that?
So let's take an example if there's a case like that. So what happens, so we do have a gateway for those cases. Now what exactly that gateway is, let's take an example on the one side, like one side is the cloud side and the other side is the private network. The cloud side also have a private network 192.168 and that same range also is present in the VPC side, that 192.168. Now what we do, we have a gateway as well. For example, the cloud servers which need the access to the gateway or the private IPs of the VPCs. So that gateway is a middleman which basically transfers the packets to the 192 range of this particular private network instead of the local 192.168. And that gateway is basically the middleman or basically the man who does the job for us. Now, in case if you wanted to access your own private network, so you do not need to go through that gateway. You directly access 192.168 in your private. So does that answer your question?
So what gateway is that?
So in the case of MiniOrange, we have our own gateway. Like that gateway basically does the job in such a way that it's a proxy sort of thing, which basically does it for us. For example, if there's a Ubuntu server, so that is a proxy for us. We just basically deploy our own connector over there, and any request which is coming on that particular server, that basically automatically gets sent to the tunnel, not to the local private IPs.
Do we have any gateway on AWS? I don't know if there is.
I need to check that if there's any gateway or a proxy sort of thing which can basically do the job for you.
Yeah.
But I'm not 100% sure about that part, like if there's any gateway. But yeah, you can build your gateway by yourself as well. Like it won't take that much of efforts as well.
Mhm.
It's basically a proxy which is doing the job for you. If you're going to the proxy, it will send you to private network. If you're not going to the proxy, it will send it to your local private network.
Okay. Yeah. Thanks.
Yeah. Any other questions? Yes.
Yeah, I have this situation and I feel like, yeah. Can you see me?
Yeah.
Yeah, I have this situation and I feel like your input would really matter. So my situation is I have a machine that's on cloud and I want to connect that cloud machine to my, let's say, home network. Then according to you, like what should my approach be? Whether it is using VPN or using firewalls and yeah.
So by default, like if it's a single machine, so I will usually recommend a SSH tunnel. So SSH tunnel, reverse SSH tunnel, I would say. So that basically gets established from your network. You will basically send a request to the cloud, and that cloud will just accept that request and send back a response, and that particular tunnel will be established. That is the one for one server, for one single server. But if you have multiple servers, in that case, establishing an IPsec tunnel will be an ideal way. Now, if you have a firewall or a VPN, you can use that for one endpoint, and the other one will automatically have, because the cloud solution does have their own VPNs. But if you do not have that, in that case, there are some open source solutions, something like StrongSwan or something like that, which you can use on your server itself, and it will hardly take like some space from your server, and that basically establish the tunnel for you. So it depends on the requirement. If there are multiple servers, I'll recommend you to go with the IPsec tunnel. But if it's a single server, go with the SS tunnel.
Okay. So just to confirm, the application that you call the name of Strong Swan.
Strong Swan.
Yeah. So will that help me establish?
Yeah, it can be used as one endpoint. Like because the IPsec tunnel requires two endpoints. One endpoint is the VPN one. If you have your own VPN, you can use that VPN. Otherwise, the endpoint can be done with the help of Strong Swan. The other endpoint, that other endpoint will always be on the cloud wherever you are using the cloud solutions. Or if it is a different private network, you can also use Strong Swan over there as well.
Okay. Okay. Thank you so much.
Yeah. Any other questions? Yeah.
To understand the case study where you would recommend the mini orange tunnel, where you feel the market AWS multi-cloud environment is not providing, and mini orange tunnel is recommended and can solve the problem.
Could you please repeat once again?
Like where you would recommend mini orange tunnel over the other tunnels available in multi-cloud environment.
It's not mini orange tunnel. It's just the endpoint which mini orange can help you with. Like for example, if you have your own VPN, we always recommend to use that VPN. If you have your own firewall, we always recommend to use your own firewall. The only thing is that if you do not have a VPN, in that case, how exactly you will establish that tunnel with the other end, or how exactly you can make that tunnel. So in that case, only we do recommend mini orange tunnel. We basically provide our own IAM solution, our own PAM solution. Now, because our PAM solution or IAM solution does require to have the customer's private network access. So in those cases, if the customer does not have that, so we basically use our own connectors to basically establish those tunnels. Yeah. Any other questions? If there's no other questions, so this is the link to the feedback. So if you guys have any feedback or if you want any sort of improvements, anything like that, you can just post it over here. That would be really, really appreciated. And my LinkedIn ID and the email address is also mentioned over here. In case if anyone have any other questions, they can ask me directly on the email. And if you want, I can also be available outside as well. Thank you so much, everyone.